Good morning, students. Welcome to Lakshya Academy YouTube channel. Okay, up to now we discuss about semiconductor devices, some part. Yeah, students. Actually, I think all of you safe at home, and I feel that I hope strongly you are safe at home. Okay, and just a revision of that graph in half minute. Isolated atom has discrete energy levels. In a solid, atoms are closely packed to each other, so energy levels of one atom may overlap with another atom, neighboring atoms. So because of that, there may be chance to overlap the energy levels of outermost electrons. So the interatomic distance is further decreased. It is very less. That means that energy band may formed. Okay. So today our topic, the explanation of conductors, insulators and semiconductors. Already you know that the definition of conductor, semiconductor and insulator. So in detail we will discuss about the conductors, insulators and semiconductors. First we discuss the concept of conductors. Conductors, the substances which allow electric current easily through them are called as conductors. The best examples are metals. Okay, the substance which allow electric current easily through them are called as conductors. Examples, all the metals are conductors. Okay dear. And the semiconductors are the substances whose conductivity lies in between the conductors and insulators. The best examples are germanium and silicon, and they have the valency of 4. Okay. And insulators, the substances which do not allow electric current easily through them are called as insulators. Wood, paper, etc. These are the examples of insulators. Okay. Conductors, substances which allow electric current easily through them are called as conductors. It means that they allow electric current through them easily in the substances like sodium, magnesium, copper, etc. In conductors, the charge carriers responsible for the conduction are free electrons. Okay dear, the free electrons are responsible for the conduction process in conductors. And maybe when the electrons are carrying the energy from one end to the another end of a conductor, there may be obstruction to that normal flow of charge carriers. So that is nothing but electrical resistance. Already you studied in our lower standard in electricity part. So the electrical resistance of conductors is very less, and electrical resistance depends on the dimensions of the conductors also. And in lower standard you studied that R equal to rho L by A, where rho is called as resistivity or specific resistance of the conductor. The resistivity or specific resistance of the conductor is the one of the physical parameter of the conductors to explain how they allow the electrons easily through them. And in conductors the conductivity is high and the resistivity is low. For example, in the case of conductors, in the case of substances, the resistance depends on temperature also. For example, in the case of conductors, as temperature increases, the resistance increases. So the physical parameter resistance is temperature dependent. That can be explained by temperature coefficient of resistance. So here I mentioned that in the case of conductors, with the increase of temperature, resistance of the conductor increases, so the temperature coefficient of resistance is positive in the case of conductors. So for conductors, the temperature coefficient of resistance alpha is positive. Temperature coefficient of resistance is denoted by alpha. For conductors, the conductivity is very high and it is in the order of the conductivity of conductors is in the order of 10 power 2 to 10 power 8 Siemens meter inverse. And the resistivity for the conductors is in the range of 10 power minus 2 to 10 power minus 8 ohm meter. And in the case of conductors, the type of bonds are metallic bonding, and these metallic bonds are weak and metals are opaque to the light. So that can be explained by when light energy falls on a conductor, that means metal surface, that light energy is absorbed by the free electrons, so they oscillate and gives out electromagnetic waves in all directions with a certain frequency, giving lustrous appearance. So that's why metals are opaque to light. And in the case of conductors, the valence band and conduction band overlaps, so the forbidden energy gap is 0 in the case of conductors. the forbidden energy gap is 0 in the case of conductors. Yeah, next we move to that semiconductors. The substances which have the conductivity values in between the values between insulators and conductors are called as semiconductors. The best examples of semiconductors are germanium and silicon, and their valency is 4. And in the case of semiconductors, there is a small gap between valence band and conduction band. That means the forbidden energy gap is in the order of 1 electron volt. For silicon, the forbidden energy gap is 1.1 electron volt at 300 Kelvin temperature and 0.78 electron volt for germanium at 300 Kelvin temperature. So in the case of semiconductors, the free electrons and holes are responsible for the conduction in the case of semiconductors. And the forbidden energy gap is about 1 electron volt in the case of semiconductors. The resistivity value in the case of semiconductor is 10 power minus 5 to 10 power 6 ohm meter, and the conductivity value is 10 power 5 to 10 power minus 6 Siemens meter inverse. And in the case of semiconductors, the bonds are covalent bonds. These are formed by covalent bonds, sharing of electrons. Okay, the free electrons and holes are responsible for the conduction process in the case of semiconductors, and I explain the concept of holes later. Next, we move to that insulators. The substances which do not allow electric current easily through them are called as insulators. Examples: wood, paper, etc. In the case of insulators, the resistivity is very high and conductivity is very low, and the resistivity ranges from 10 power 11 to 10 power 19 ohm meter in the case of insulators. And in the case of insulators, the conductivity is low and it is in the order of 10 power minus 11 to 10 power minus 19 Siemens meter inverse. The reciprocal of resistivity is called conductivity. And in the case of insulators, there is a big gap between valence band and conduction band. So forbidden energy gap is more in the case of insulators. It is more than 3 electron volt. Okay, this is the brief description about conductors, semiconductors and insulators. And at absolute zero, semiconductors behaves as an insulators, because at absolute zero in semiconductors there are no free electrons in the conduction band. So at absolute zero, semiconductors behaves as insulators. Okay, dear. So distinguish between semiconductors, insulators and conductors. Okay, note down the points and write down the notes. Okay students, once again I brief the conductors, semiconductors and insulators. Now already you know the definition, I am not going to repeat that. And conductivity property. For conductors, conductivity is high. For semiconductors, conductivity is moderate. And for insulators, conductivity is low. Forbidden energy gap. For conductors, conduction band and valence band overlap with each other. There is no forbidden energy gap. But in the case of semiconductors, there is small gap between conduction band and valence band. So the forbidden energy gap is about 1 electron volt in the case of semiconductors. And in the case of insulators, there is large gap between conduction band and valence band. So forbidden energy gap is about more than 3 electron volt. The resistivity is low in the case of conductors and moderate for semiconductors, and for insulators it is very high. For conductors, with the increase of temperature, the resistance increases, conduction decreases. So the temperature coefficient of resistance is positive in the case of conductors, and for semiconductors, with the rise of temperature, conduction increases, resistance decreases. So the temperature coefficient of resistance is negative. For insulators also, temperature coefficient of resistance is negative. The conductivity value for conductors is 10 power 2 to 10 power 8 Siemens meter inverse. For semiconductors, 10 power 5 to 10 power minus 6 Siemens meter inverse. For insulators, 10 power minus 11 to 10 power minus 19 Siemens meter inverse. Next, the resistivity value. For conductors, the resistivity value is 10 power minus 2 to 10 power minus 8 ohm meter, and for semiconductors, 10 power minus 5 to 10 power 6 ohm meter. For insulators, very high, 10 power 11 to 10 power 19 ohm meter. Current flow. So in conductors, current flow is due to electrons only. But in the case of semiconductors, conduction is due to both electrons and holes. And in the case of insulators, there is current flow is with negligibly small. There is no flow. And overlapping of bands. In the case of conductors, conduction band and valence band overlap with each other, and there is small gap between for semiconductors between conduction band and valence band. There is large gap between conduction band and valence band in the case of semiconductors. Type of bonds. Semiconductors, the nature of the bonds are metallic bonds, and semiconductors formed by covalent bonds. In the case of insulators, the bonds are ionic bonds. Students, the diagram shows the conduction band and valence band and energy gap between the conduction band and valence band, and forever understand I have given that, and please observe that. And insulators have large energy gap, and semiconductors have small energy gap, conductors has no gap. Okay, just observe carefully. And in this diagram I mentioned the Fermi level also. So Fermi level and I discuss later, and concept of holes and Fermi level, and tomorrow I will discuss, next class I will discuss. And okay students, this is the explanation of conductors, semiconductors and insulators. And tomorrow and we move to types of semiconductors, pure semiconductor and impure semiconductor. Okay, be safe, stay at home. Thank you so much.